In this question, we're told that a car is moving along a straight horizontal road. At time t equals 0, the car passes a point A with a speed 25 meters per second. So that means at the beginning of the journey or the beginning of our observation, the car is traveling at 25 meters per second. The car moves with a constant speed, 25 meters per second, until 10 seconds. I'm going to start to sketch this. So let's get our axes. We've got the velocity and we've got the time axis. And the first 10 seconds, there's constant velocity of 25. So I'm just going to mark off the 25 and the 10, and a horizontal line will show that constant velocity. Okay, I continue reading. It tells us that the car then decelerates uniformly for 8 seconds. At the time 18 seconds, the speed of the car is v meters per second. Okay, so over the next 8 seconds, the speed needs to reduce, the velocity needs to reduce down to v. V's unknown, but we know it needs to reduce to v. So I'm just going to show the intervals here. So here's a 10-second interval to begin with, and then we have an 8-second interval. And in this time, it reduces its velocity down to v. So a negative gradient. Okay, continue reading, and we're told that this speed is maintained until the car reaches the point B, and that will be after 30 seconds. So we've had 18 seconds so far. The last period of time needs to be 12 seconds. This 12-second period, we have constant velocity. This is where we get to. Okay, so I'm happy with the diagram, and part A of the question wanted me to sketch it anyway. Whether I was told to or not, that would be the decision that I make to make a sketch so I can really see what's happening throughout the question. Next, we're told that AB, the distance from the start to the end, is 526 meters, and we've been asked to find V. Well, we know that distance equals area in a velocity time graph. So I'm going to split the shape into 3 distinct shapes which I can find the area for. And I've added the dimensions of each of those shapes just to make the next step of my work smooth. We're going to form an equation. 526 equals 25 times 10 plus the area of the trapezium plus the area of the final rectangle. Simplifying each of these, this is the expression that we get. And rearranging, we get V equals 11. So the velocity that we reduced down to was 11 meters per second. Okay, part C of the question. We're asked to find the deceleration between 10 seconds and 18 seconds. So for this 8-second period of time, what is the deceleration? What is the change in velocity? So we're focusing on this part of the diagram, which means I can use suvat because there's constant acceleration over this segment of the journey. Initial velocity of 25, final velocity of 11. We're looking for the acceleration. Time equals 8. Substitute these into the appropriate formula, and we get acceleration negative 1.75. Now we know this is a deceleration, but it's perfectly fine to leave this as A equals negative 1.75.